number one asks us to find the inverse of the function of f of x. And that's what this symbol means right here, the inverse. Okay, now when you want to find the inverse, what you do is you switch the x and the y within your equation. So since technically f of x means y equals, we're going to change this y to an x. And we're going to change both of these x's right here to y's. All right, now what we want to do here is we want to take this equation and we want to solve for y. Okay, so I think the best thing to do here is, since we have a y in both the numerator and denominator of this fraction, I think we should just take this side of the equation, the left side, and make it into a fraction by putting it over 1 and just cross multiply. So when we take the x and multiply it by y minus 2, we're going to do, let me write this out. I'll rewrite it as x times y minus 2. And then I'll bring down the equal sign. Okay, so I just multiply the top left by the bottom right. And then when I multiply y plus 1 times 1, that gives me y plus 1. Okay, so let's distribute the x, so that gives us xy minus 2x equals y plus 1. Okay, so now in order to solve for y, you want to get both terms that contain the y on the same side of the equation. So here we have an xy, and here we have a y. So I want to get them both to the same side of the equation. Now, I think, just kind of looking ahead, I think what I'm going to do is I'm going to leave this here and move this y over, because then I'll move everything else to the right-hand side, and it makes sense to move the other terms to the right-hand side, because if this is a negative 2x, when I move it to the right, it'll become a positive 2x, and we have a positive 1. So might as well bring those over and have positive terms. Okay, so let's do that. So I'm going to subtract the y from both sides of the equation. So these are going to cancel. And then at the same time, let me get rid of this negative 2x. I'll add the 2x to both sides of the equation. So these are going to cancel. All right, so on the right-hand side, I have a positive 1 and a positive 2x. I'm going to order that as 2x plus 1. And then on the left-hand side of the equation, these were not like terms. Okay, just like these weren't like terms because this term had an x and this one didn't. These are not like terms because this term has an x and this one didn't. So we're going to just leave them separate as xy minus y. Okay, now we're still trying to solve for y, and y is contained within both of these two terms. So really the only way to get the, well, not the only way, but I feel like the easiest way to get the y out of both of these two terms is to factor it out. So if I factor out the greatest common factor of y, then in parentheses, right, if I factor y out of this term, it leaves me with an x down here. And then I'll bring down my minus sign. And if I factor a y out of this term, y divided by y is just 1. So that leaves me with x minus 1 in parentheses. And then finally, to get the y by itself, let's just divide both sides by what it's being multiplied by. So we'll divide both sides by x minus 1. And that leaves me with y equals 2x plus 1 over x minus 1. Now, since we technically didn't start off with a y, right, we started off with f of x, I'm going to change this back to f of x, but because it's the inverse, we write our inverse symbol like this. So I'm going to rewrite this. You know what I'm going to do? I'm just going to erase that. And let's just rewrite that as f inverse of x. Okay, so it looks like that is choice 2. Okay, we always like to do, this is multiple choice. So if we can use a calculator cheat method to help us, definitely take advantage of that, all right? So, whatever you do to get the question right. So here, right, if we take our original function and plug it into y1 in the calculator, and you will have to go through answer choice by answer choice, but once we get to the second answer choice, when you take this equation and plug it into y2 in the calculator, we know inverse, right? We know inverse means that the x and y values are switched. So if we take a look at the table of values, they should have x and y. If they're inverse functions, they should have x and y values that are switched. So if you look at y1, right, when x is negative 1, y1 is equal to 0. Now, doesn't that mean that the other function, its inverse function, should go through the point 0, negative 1, right? These coordinates should be reversed. And check this out right here. Ready? When x is 0, y2 is equal to negative 1. Okay, so those are flip-flop. Okay, first function goes through -1, 0. This goes through 0, -1. Now you want to make sure that that consistently happens. It doesn't just happen for one set of points, so let's keep going. So you want to look for whole number points. All right, I'm just going to look at what I have on the screen here. When x is equal to 3, y is equal to 4. That means the other function should go through the coordinate 4, 3. And if you look here, it does. Look, when x is 4, y, 2, is equal to 3. And if you scroll up and down your table of values, you'll see that this happens, infinitely many times. Okay, number 2, which expression has been rewritten correctly to form a true statement? Now, let's be honest, this is multiple choice. You have your calculator. I mean, I honestly think the probably easiest way to do it is just to plug in this left-hand side of the equation into your calculator and hit enter. Plug in the right-hand side of the equation into your calculator and hit enter, and see if they match. If so, it's a true statement. If not, on to the next. Just make sure that your x is not stored as 0, 1, or -1, because sometimes things will appear to check. Your best bet is to store it as some random number like 5.23. Same thing with your y. Make sure the x and y are both stored as some unique numbers. And that's that. I mean, if you want to see it by hand, choice 1 is the answer, and I'll just show you why. If you take the left-hand side of the equation and just, write it out. I'm going to write the x plus 2 squared as x plus 2 times x plus 2, right? Because if we square something, it means we have 2 of them. I'm just going to write out the left-hand side of the equation. All right, so if we double distribute out the left-hand side of the equation, it gives us x squared plus 2x plus 2x plus 4. And then I'll distribute the 2 to both terms, giving me 2x plus 4, and I'll bring down the minus 8. All right, so let's combine our like terms. So I have an x squared, and then 2x, 2x, and 2x combine to give me 6x. And then 4 plus 4 minus 8 just cancels out, right? Positive 4 and positive 4 is positive 8, and 8 minus 8 is nothing. Okay, so it leaves us with x squared plus 6x. So if I want to try to get that to look like the right-hand side of the equation, all I have to do is just factor out an x, which would leave me with x plus 6 in parentheses. So that one's true. That one checks out. Okay, number 3 is a nice easy one as long as you know your formula for margin of error. Now, if you look at the answer choices, there's 2 things they want us to find. They want us to find the proportion and the margin of error. Now, the proportion is really like the proportion of successes. Okay, the outcome we expect to happen. So when you read this question, if you go back and read it, since the study found that 212 out of 1,334 participants had hypertension, if we want to figure out P, the proportion of successes, you would just divide those 2 numbers. This would be the expected outcome. And when you do 212 divided by 1334 in your calculator, it gives you approximately 0.16. Okay, so we can see that choice 1 and 2 have P being 0.16, and 3 and 4 don't, so we can eliminate those. Okay, now, your formula for margin of error at a 95% confidence level, I mean, your margin of error is equal to 2 standard deviations, which they don't give us here. So we're going to have to use this other formula for margin of error. Okay, so we know that P, we already found that to be 0.16. Q is just 1 minus P, so 1 minus 0.16 will give you 0.84. And N is your sample size. So in this case, we had 1,334 participants. And make sure, I'm going to make my radical even bigger. Make sure not just the numerator is under the radical, but the denominator as well. Okay, so all you're really going to do is just plug all of this into your calculator and see what you get. So when you do, that is approximately 0.02. So that would be choice 2. Okay, so number 4, which scenario is best described as an observational study? Now, just to remind you, in an observational study, subjects are observed as they are without any manipulation at all by the researcher. All right, so number 1. For a class project, students in health class ask every 10 student entering the school if they eat breakfast in the morning. Okay, that one I would say would be more of a survey because they're asking, people a question. So that one I would say probably is not the choice. That one would be a survey. I'm going to jump over to choice 3. This one over here. A researcher wants to learn whether or not there is a link between children's daily amount of physical activity and their overall energy level. During lunch at the local school, she distributed a short questionnaire. So that, again, sounds like a survey to students in the cafeteria. So I'm going to say that one I would say is more of a survey as well. All right, choice 2. A social researcher wants to learn whether or not there is a link between attendance and grades. She gathers data from 15 school districts. Okay, that right there I would say is the observational study. That's going to be our answer because she's not distributing a survey. She's not asking people questions. She's just really gathering data without manipulating the environment at all. She's just gathering data. Okay, and then choice 4, 60 seniors are taking a course in 60 seniors taking a course in advanced algebra concepts are randomly divided into 2 classes. One class uses a graphing calculator all the time, and the other class never uses graphing calculators. I'm going to stop right here. As soon as we see this, they're randomly divided into 2 classes, and one is giving calculators and the other isn't. We could see right there that's called an experiment, okay, because they're giving each group a different treatment. So that one, definitely not. They're randomly. Remember, with an experiment, you want to see that word randomly. But that right there is an experiment. Okay, number 5. Jasmine decides to put $100 in a savings account each month. The account pays 5% annual interest, compounded monthly. How much money S will Jasmine have after 1 year? Okay, so they're kind of giving you a clue right here that you're going to use your S sub n formula, okay, the sum of a geometric, we know it's a geometric sequence because it's going up by a percent. So if you look on your reference sheet, you don't even have to memorize this one. This one's given right to you. S sub n equals the first term minus the first term times r to the n power over 1 minus r. Okay, so we're looking for how much will she have after 1 year, and it's paying out, it's compounded monthly, so it's paying each month. Okay, so we're looking, since there's 12 months in a year, we're looking for the sum of the first 12 months. Now, a sub 1, the first term, is the $100 that she put in the account each month. So we're going to replace the a sub 1 with 100. Okay, the rate, now this is where it gets a little tricky because it's compounded monthly. This word compound tells us that we're going to have to use our compound interest formula. All right, now, sorry, it's not letting me write up here. Now, really, all we need is the inside of this formula, okay, the 1 plus, since the rate is 0.03, and the n would be 12, right? Because there's 12 months in a year. This is supposed to be a 3. This is the part of the formula that we want to plug in for the rate. Now, you can plug in your calculator 1 plus 0.03 divided by 12, and it gives you 1.0025. Okay, so that's what we're going to substitute in for our rate here. That's the rate at which it's growing per month. Okay, and then we're going to replace the n with a 12. Okay, just like we did here. If we replace this n with a 12, we want to replace this n with a 12. And then in the denominator, it's just going to be 1 minus this monthly, increase rate that we found right here. So 1.0025. Okay, so they don't even have you do anything with it. They just want to know which one shows this. So choice 2 would be the answer. All right, number 6. According to a pricing website, Android phone loses 58% of their cash value over 1.5 years. Which expression can be used to estimate the value of a $300 Android phone in 1.5 years? Okay, so if you look at these answer choices, you could see right here that it totally appears to be following this formula that we know. And also, all of these answer choices have negative exponents because it's losing. Let me underline that. It's losing 58% of its value. Okay, so let's just plug in the numbers. I mean, they really only, the answer choices only have the right-hand side of this equation. So P would be the initial amount of the phone, which is $300, which I guess that doesn't help us because they all have that. The rate, since it's losing, they're using a negative for a loss of 58% of its value, and that's over a year and a half. So for time, I'm going to plug in 1.5. All right, and then we have 300e, and at this point, all you really have to do is figure out what negative 0.58 times 1.5 is, and it's equal to negative 0.87. So that would be choice 1. Okay, number 7 is a nice, quick, easy one. So relative to the graph of y equals 3 sine of x, what is the shift of this graph? Now, we know if something is being added or subtracted within the parentheses, it shifts the graph left or right. And if something is being added outside the parentheses or subtracted, it's moving it up or down. Now, remember, if we see an addition sign here, it's actually moving to the left. Okay, if we saw a minus pi over 3, it'd be moving it to the right. So this is moving it pi over 3 units left. So choice 2. Okay, so number 8 just wants to know over which interval is the volume of the box changing at the fastest rate. So if you want to figure out what rate it's changing at, you're just using your average rate of change formula. So you're just going to want to go through the answer choices one by one and figure out the average rate of change and see which one is the greatest, okay? The fastest. All right, so let's start with answer choice 1. Now, when they give you this interval, they're actually giving you the domain. They're saying that this first number here, the 1, represents x1, and they're saying that this second number here represents x2. So this is the domain. We're looking at all values from 1 to 2. So let's look at our graph. When x is equal to 1, looks like the coordinate of that would be 1, 0. And when x is equal to 2, looks like the coordinate of that would be 2, 9. All right, so let's start here, choice 1. So if we're going to use our average rate of change formula, you're just going to do y2 minus y1. So we're going to take these y values and subtract them. So we'll do 9 minus 0 over, and then x2 minus x1. So we're going to take our x values and subtract them. So 2 minus 1. Okay, so one thing I just want to point out, it doesn't matter whether you do 9 minus 0 over 2 minus 1, or if you do 0 minus 9 over 1 minus 2. As long as if you start with y2, you have to start with x2. Okay, so if you start with this y value, you have to start with this x value. Okay, so 9 minus 0 is 9, and 2 minus 1 is 1, so that simplifies to 1. I'm sorry, to 9. All right, so let's do the same thing for all the answer choices. All right, so then we'll go on to number 2. So here's our x1, and here's our x2. So we already know that at 1, when x is 1, y is 0. Now they're saying, let's look at when x is 3.5. So 3.5 would be up here. So the coordinates of that would be 3.5, 17. All right, so let's do the same thing. So we're going to do y minus y over x minus x. So 17 minus 0 over 3.5 minus 1. So 17 minus 0 is 17, and 3.5 minus 1 is 2.5. And if you divide those, you end up getting 6.8. So far, choice 1 is larger, so it definitely can't be choice 2. So I'm just going to cross that answer right off. Okay, now let's go to choice 3. So now we're looking at, let me switch to this pen, when an x1 of 1 and an x2 of 5. Okay, so we're back at this point again. So x1, when x is 1, y is 0. When x is 5, y is also 0. So if we use our average rate of change formula here, if we do y minus y over x minus x, you're going to wind up having 0 minus 0 over 5 minus 1, which 0 divided by 4 just simplifies to 0. So that's definitely not our answer either. That one's not even changing. All right, so let's take a look at choice 4, and it's got to be either 1 or 4. Okay, so choice 4 wants us to use the domain from 0 to 3.5. Okay, so when x is 0, y is negative 5. And again, we're using this point when x is 3.5, y is 17. All right, so let's do our formula again. So y minus y over x minus x. So 17 minus negative 5. I'm going to write that out like that. 17 minus negative 5. So that would be, if you have a minus negative, that becomes plus. Okay, and that's going to be over 3.5 minus 0. All right, so 17 plus 5 is 22, and 3.5 minus 0 is 3.5. And if you simplify that, you don't get an exact value, but it's approximately 6.3, which is less than this average rate of change of 9 in choice 1. So looks like choice 1, the very first one we did, was our answer. So number 9, which statement regarding the graphs of the functions below is untrue? Okay, so let's just kind of highlight that word a little bit, untrue. All right, so what I did was I actually graphed each one of these functions one by one, and that's, I think, what takes the longest of this. So the first function, f of x. So it says f of x equals 3 sine of 2x. And the only way to graph it from negative pi to positive pi. So if we go back pi units, and if we progress up pi units, what we're going to do is we need to fit, we know the frequency is 2, so it means we're going to fit 2 sine curves between 0 and 2 pi. So if we're fitting 2 sine curves between 0 and 2 pi, right, that's what frequency means, then it means we're only going to fit one of these between 0 and pi. So all I did, since the amplitude is 3, I just graphed a sine curve with an amplitude of 3 between 0 and pi. And then we would have another complete cycle between negative pi and 0. All right, this you can just plug into your calculator and look at the graph, and that's what we have. Or you could just say my zeros would be at positive 0.5, negative 4, and positive 2. So you can just sketch, you could just, sketch those on the axis, and we know since it's a positive leading coefficient, it's going to go up, down, and back up. Okay, so log base 2 of x. If you forget how to get log base in your calculator, you just go to math. Once you go to y equals, you go to math and you scroll all the way down until you get to letter A, which says log base. And, you can go to your table of values if you want, but you'll see this is the graph. Okay, it goes through the point 1, 0. And as the x values get bigger, so do the y values. And as the x values get closer and closer and closer to 0, the y values go down. So this actually is never going to hit the y-axis. It's just going to get closer and closer to it. Okay, and then finally, j of x, this last one here, I would just go to y equals in my calculator and plug this in and just kind of copy the points from the table of values. And we could see, an absolute value graph is going to look like a V. And since it's negative, it's upside down. Okay, so let's go through the answer choices. Choice 1, f of x, which is right here, and j of x, which is right here, have a maximum y value of 3. So let's see, j of x has a maximum y value of 3, and so does f of x. So that's a true statement. So that cannot be our answer because we're looking for what is untrue. Okay, choice 2, f of x, h of x, and j of x have one y-intercept. Okay, so let's start with f of x. F of x, well, that's true. That only has one y-intercept. Okay, the y-intercept is where the graph crosses the y-axis, so there's only one spot right here. H of x, which is right here, well, that's not going to have a y-intercept because it's going to come closer and closer to the y-axis without actually touching it. That's why our y-axis, or the equation x equals 0, is called an asymptote. Okay, so this right here, this has got to be the false statement because that doesn't have any y-intercept. So that is our answer. if you want to keep listening as to why the other choices are true, you can. Okay, so g of x and j of x have the same end behavior as x approaches negative infinity. All right, so here's g of x and here's j of x. As x approaches negative infinity, so what that means is as we go, to the left along our x-axis, as the x values get smaller and smaller, what's happening to the y values? Well, here, as the x values get smaller, the graph is going down, so the y values are approaching negative infinity. Same thing here. As your x values are getting smaller, the graph is going down. Your y values are approaching negative infinity. So that is true. They both have the same end behavior. Oop, I'm going to cross that off actually, as x approaches negative infinity. And then choice 4 says g of x, h of x, and j of x have rational zeros. So g of x definitely has rational zeros. Okay, this one is at -4. This one is at 0.5, which is a terminating decimal, so that's rational, and at +2, so that's true. The 0 for h of x is right here at 1, 0, and 1 is x equals 1 is rational. And then right here and here, it says j of x has rational zeros. At 0 and at 1, those are both rational numbers as well. So that is a true statement. So choice 4 is not our answer either. Okay, so number 10, a rabbit population doubles every 4 weeks. So when something doubles, right, we can use our doubling formula. It's really similar to the half-life formula. The half-life formula has a 1/2 because it's being cut in half, whereas the doubling formula has a 2 because it's doubling. It's being multiplied by 2. And then you take the time that has passed as your exponent and divide it by the half-life in the half-life formula, or the doubling time period in the doubling formula. Okay, so we're going to use this formula right here. All right, so it says a rabbit population doubles every 4 weeks. There are currently 5 rabbits, so this is the initial amount of rabbits. So we're going to replace the p with 5. So let's see, we have a equals 5, and then it's being doubled. If t represents the time period in weeks, so t is the time period in weeks, and p of t is the population of rabbits with respect to time, about how many rabbits will there be in 98 days? Okay, so they're saying that t represents the time period in weeks. So because it takes 4 weeks to double, I'm going to replace the d, the doubling time period, with a 4. Now, they give us the time that has passed in days. We want to convert 98 days to weeks. So if you want to do that, just take 98 and divide it by 7 days in a week. And that'll give you, what does that give you, 14? Okay, so I'm going to replace 14 with the time. Okay, so then all we have to do is just figure out what 5 times 2 to the 14 divided by 4 is 3.5. So you can just plug this in your calculator and see what that's equal to. So when you do, you get approximately 56.57. So that's a decimal. So I would say that's 57 rabbits, but because they use the word about, okay, give or take a little, their answer is 56 rabbits. Now, I just want to say, I actually, on the written out answer key, I actually did this a different way. Instead of using time in weeks here, I used time in days. So another way you could have done this, you'll get the same exact answer, as we started off with 5 and they're doubling, and I just put the 98 days, the time that has passed, over, and if you convert 4 weeks to days, wouldn't that be 28 days? But 98 divided by 28 is still 3.5, so you'll still get the same answer in the end. Okay, so number 11 wants to know which statement about statistical analysis is false, or which is not true. Okay, so choice 1 says, experiments can suggest patterns and relationships in data. Yes, experiments can, observational studies, surveys. That's why we perform statistical studies, to look for patterns and relationships. So that's a true statement, so that's not our answer. Okay, choice 2. Experiments can determine cause and effect relationships. Yes, This is a true statement. Experiments are actually the only thing that can determine cause and effect relationships. When you randomly divide subjects into two groups and keep everything the same other than, the factor that you're testing for, you can say it was because of that factor. So experiments are the only thing that can determine cause and effect relationships. So that's true. That is not our answer. Choice 3 says observational studies can determine cause and effect relationships. That is not true. That's our answer. Okay, again, experiments are the only thing that can determine that. Nothing else. Not observational studies, surveys. Okay, and then choice 4, observational studies can suggest patterns and relationships in data. Yes, that is very true. Okay, that's why we conduct them. Number 12 wants to know which of the following answer choices is equivalent to this original expression. Now, this is a total calculator cheat question. If you don't know how to do it, you can take this entire thing and use alpha y equals and plug it into your calculator exactly like you see it. And if it's easier, just use x instead of m. And then you can go through and plug in these answer choices one by one to see which one matches up. And remember, to get something like the 6th root or the 5th root, you would have to go to math and just scroll down until you see the xth root. Okay, but I'm going to show you how to do this by hand. So you could start this a couple different ways. I'm going to start off, you could either distribute this exponent to the numerator and the denominator by, if you have a power raised to another power, multiplying these. But I'm going to actually take this inside the parentheses. I'm going to take these two terms, and I'm going to make them into one term. So if you're dividing two terms with the same base, all we do is we subtract these exponents. Okay, so I'm just going to put that here. We're going to do 2 minus 1/3. You're just going to subtract them. So if you want to find a common denominator, the common denominator would be 3. So then that would give us 6/3 minus 1/3, which would be 5/3. Okay, so what we're going to do is we're going to keep this base of m, and when we subtracted the exponents, we got 5/3. And then I'll just bring down the negative 1/2 power. Okay, so now when we have a power raised to another power like this, what we're going to do is we're going to multiply these. So you could just multiply the numerators and multiply the denominators. So first of all, a positive times a negative is a negative. And then 5 times 1 is 5, and 3 times 2 is 6. So we get 5/6. All right, so now we have a negative exponent here. Now we know to get rid of a negative exponent, we make this into a fraction, and you're going to move the term with the negative exponent on it to the opposite side of the fraction bar. So since this m to the negative 5/6 is in the numerator, when we move it down to the denominator, it becomes m to the positive 5/6. And then we put a placeholder of 1 on top. And then to finish this up, you can see all the answer choices are written in radical form. So if you think about the power over root, we can rewrite this as the 6th root of m to the 5th power. And it looks like that is choice 2. Number 13 just wants us to find the inverse of this function. Now when we see inverse, we know we have to switch the x and the y. So I'm going to rewrite this as x equals log base 3 of y. Okay, so now we want to solve for y, and in order to do that, I don't know if you remember this rule, we haven't seen this in a while, but you want to get rid of the word log. We want to circle the base and run the race. Okay, so circle the base and run the race. And what that means is this 3 is now going to become the base on the other side of the equation. So this side of the equation will have base 3 to the x power. And when we move this base here, the word log drops off, so we're left with just y. So this is the inverse equation, which is choice 3. Now, if you had no idea how to do this, another way is you can just use your calculator and you can totally cheat. So let me show you how to do that. Okay, so what you're going to do is you're going to, in your calculator, go to y equals and plug in the original function. And then you're going to have to plug in the answer choices one by one into y2. Although you really can't plug in choice 4 because that's x equals. But when you get to choice 3, you'll have y equals 3 to the x. Now remember, inverse means that the x and y values are changed. So what you're going to do now is you're going to go to the table of values. And remember, if they're inverse functions, like we just said, the x and y values are flip-flopped. They're switched, right? So if you look here, see this? Actually, let me make this a little bigger so we can see this better. Okay, so when x is equal to 0, y2 is equal to 1. That means the other function will go through the point 1, 0. And look, it does. 1, 0. Okay, so this is 0, 1, and this is 1, 0. Let's take a look at another point. So here we have one, ready? This function goes through the point 3, 1. So y2 should go through the point 1, 3. And it does. So you could totally use your calculator to find the answer as well. Okay, so they give us a picture of p of x, and they want to know which equation could represent p of x. All right, so the really easy way to do this is just go in your calculator and go to y equals and plug these in one by one and see which one looks like this. That's really the easiest way. If you want to do this another method, you could say, all right, well, it has zeros at x equals -3, at x equals +2, and at x equals +3. So that being said, without worrying about the leading coefficient, although all these answer choices, if you look, they all have a leading coefficient of 1 anyway. But if we have a factor of x minus 3, if we have a 0 of x minus 3, the factor that corresponds with that would be x plus 3. If we have a factor of, if we have a 0 of x equals 2, the factor that would correspond with that would be x minus 2. And if we have a 0 of x equals +3, the factor that would correspond with that would be x minus 3. All right, so if you look at the answer choices, actually I'm kind of looking ahead. What I'm going to do is I'm going to rearrange my factors. So I have the x plus 3 and the x minus 3 first, and then I'll take that x minus 2 and write it last. All I did was I moved this factor here and moved that factor here. Now if we were to double distribute this, it would give us x squared minus 3x plus 3x minus 9. So that minus 3x and the plus 3x would cancel off, leaving us with just x squared minus 9. And you should recognize that anyway, right? Isn't this dots? This is a difference of perfect squares. It factors to x plus 3, x minus 3. Okay, and then I'm just going to take this x minus 2 and just bring it right down. So that is choice 1. Number 15, Cheap and Fast Gas Station is conducting a customer satisfaction survey. Which method of collecting data would most likely lead to a bias sample? Okay, so bias just means unfair. So we're looking for which would lead to an unfair sample. Okay, so choice 1, interviewing every 5th customer to come into the station. Well, that's a good way to produce a fair sample. That's just randomly selecting people. Okay, interviewing customers chosen at random by a computer at the checkout. That's a fair way as well, because that's also done randomly. They're not handpicking who, responds. Choice 3, interviewing customers who call an 800 number posted on the customer's receipts. Okay, this is going to be our answer. This usually creates an unfair or a biased sample, because when you ask people to call into a number, it's usually people who are going to feel, passionate about something. So in this case, it would probably be about, the calls would probably be from customers who receive like really, really bad service or even really good service. It probably wouldn't just be your average, customer who received average service. They just, they probably wouldn't be bothered. Okay, and then choice 4, interviewing every customer who comes into the station on a day of the week chosen at random out of a hat. Well, that's a random way to ask people as well. So that would that's a fair method. So choice 3 is the answer. All right, when I look at number 16, I'm looking at the answer choices here, and the majority of them have ln within them, and I usually, ln is usually used to get rid of an e. So I'm just going to solve this, and then we'll go through the answer choices, and we'll kind of figure it out from there. All right, so if we were going to solve this equation, we can see that the x is an exponent that's on the base of 2. So the first thing we're going to want to do is we're going to want to get this base of 2 all by itself. So let's divide both sides of the equation by 8. And that'll leave us with 2 base x plus 3 equals 6. Okay, 48 divided by 8 is 6. All right, so now if you have an exponent that contains a variable, what we do is we put the word log in front of both sides of the equation, because log rules tell us you can take an exponent and bring it to the front of the word log. That's called the power rule. So we could take that x plus 3. I'm going to group it in parentheses just because it's, it's a binomial expression. And we can bring it in front of the log 2. Okay, so now we're trying to get the x by itself. So since it's, grouped in parentheses with the 3, and it's being multiplied by log 2, to get rid of the log 2, let's divide both sides by log 2. All right, so that leaves us with x plus 3 equals, and I'm just going to leave this as, well, I guess we can plug this in our calculator if we want for now. If we plug that in our calculator, it looks like we get approximately, I'm going to make the approximate symbol, 2.585. And then when we subtract 3 from both sides of the equation, we wind up getting x to be approximately negative 0.415. Okay, now I think what I would do is I would just plug these in we know it's not choice 2, because choice 2 says that x is 0. But I would just plug each of these in my calculator one by one and see which one is equivalent to approximately negative 0.415. And when you do that, you see choice 1 is equal to that same value. So for number 17, they want to know which of the answer choices is equivalent to the given expression. Now, to be honest, you can totally, again, cheat and do this in your calculator. You can type in this original question into your calculator and hit enter. Okay, whatever x is stored as is fine. Just, pick a number other than 1, negative 1, or 0. And then plug in the answer choices one by one and see which one matches up. All right, but I'm going to do this by hand. So to do this by hand, all right, so first thing, I guess we could take what's on the outside of the parentheses and distribute it to the inside of the parentheses. So 6 times negative 4 is negative 24. X times x is x squared. And I cubed times I to the first is I to the fourth. Okay, and then we're just going to take this and distribute it to the 5. So 6 times 5 is 30. So that gives us plus 30 xi cubed. All right, so we don't want to leave i's with exponents on them. So, honestly, you can just plug this into your calculator, I to the 4th power, and it'll tell you that it's equal to positive 1. So this term, bring everything down and replace the I to the 4th positive 1. And you can plug I cubed into the calculator, and you'll see that it's equal to negative I. Okay, so then basically 1 times anything is itself. So I'm going to just rewrite that as negative 24 x squared. And then if we multiply a positive times a negative, we get negative 30 xi. All right, so that's choice 2. Okay, so number 18 is a lot of reading. Gabriel performed an experiment to see if planting 13 tomato plants in black plastic mulch leads to larger tomatoes than if 13 plants are planted without mulch. He observed that the average weight of the tomatoes from tomato plants grown in black plastic mulch was 5 ounces greater than those from the plants planted without mulch. So the ones with mulch were 5 ounces greater than the ones without mulch. To determine if the observed difference is statistically significant, he re-randomized the tomato groups 100 times to study these random differences in the mean weights. The output of a simulation is summarized in the dot plot below. Okay, so first of all, let's figure out where positive 5, lies within this distribution. So you can see if this is where 0 is and this is where 10 is, right? 5 would be right here. So right in between these two dots. So we want to look at anything that's 5 ounces or greater and determine if that's statistically significant. Now, you could see right off the bat that that occurs many times. But if you want to, find out exactly what percentage of the time it occurs, you can count up your dots. So 1, 2, 3, keep going. And there's 34 dots here out of 100 dots in the total distribution. So there's 34 total dots here, and since 34 out of 100 is 34%, we can see that a difference of 5 is a total normal usual occurrence. So this difference was not due, if it's a usual occurrence, it's not due to the black plastic mulch. It was just due to random grouping, right? Whichever plants were placed in which group. Okay, so let's read the question. Let's read the answer choices. Given these results, what is an appropriate inference that can be drawn? All right, choice 1. There was no effect observed between the two groups. Well, that's not true. No effect would mean that there is no difference. We'd be on 0 here, so that's not our choice. Okay, choice 2. There was an effect observed that could be due to random assignment of plants to the groups. Yeah, that's it, exactly. There was a difference, and because it was a normal occurrence, it was just due to which plants were placed in which group. So random assignment of the group. So that's your answers. Just to go through the others if you're not sure. Choice 3, there is strong evidence to support the hypothesis that tomatoes from plants planted in black plastic mulch are larger than those planted without mulch. This would be the answer if we wound up with something that, a difference that was so extreme that it rarely ever occurs that it had to be due to the black plastic mulch. So this would be the answer if you find something, that is statistically significant, something that occurs less than 5% of the time. All right, and then choice 4, there is strong evidence to support the hypothesis that tomatoes from plants planted without mulch are larger than those planted in black plastic mulch. Okay, this is definitely not the answer because they found the opposite results right here. So that one you could just eliminate altogether. Number 19 is a tricky one. Again, you can do this you could do this in your calculator if you want. You can just make sure, x and y are both stored as something other than 0, -1 or +1. And you could just plug this whole thing in your calculator and hit enter and plug in the answer choices one by one and hit enter and see what matches up. Now, the answer choices are a little tricky to plug in because, I would probably use alpha y equals to set this up so you have a numerator and a denominator. And then to get like the cube root, you would just go to math and scroll down to choice 4. But you could totally do it that way. I'm just going to show you how to do it by hand, though. So, all right, let's do this first. If we have an exponent of a 2/3 on the outside of the parentheses, we can individually take this exponent and place it on each term within the parenthesis. So really, we could take the -54 and raise it to the 2/3 power. I'll do this off to the side here. Just make sure you put the -54 in parentheses. Then we can take the x to the 9th and raise that to the 2/3 power. And then we can take the y to the 4th in the denominator and raise that to the 2/3 power. All right, so let's go through. Now, we know if we use power over root, right, power over root, for each of these, this will become the cube root of -54 to the 2nd power. So we'll have the cube root of -54 to the 2nd power. Now, with these other two, if you have a power being raised to another power, you can just multiply these. So if you take this 9 and put it over 1, if you multiply your numerators, 9 times 2 is 18, and 1 times 3 is 3, and 18 divided by 3 is 6. So basically 9 times 2/3 is equal to 6. All right, so I'll rewrite this as x to the 6th power. Okay, and then on the bottom, I'm going to actually do the same thing down here. I'm going to take this 4 and put it over 1. So if you multiply this power by this power, you wind up with 8/3, which doesn't simplify, so we'll leave that as y to the 8/3 power. All right, so we still have a big mess. Doesn't look anything like the answer choices so far. Although every answer choice does have this x to the 6th, right? So at least we know we're on the right track. All right, so let's start with the cube root of -54. Now, cube root means what number times itself gives you what's under the radical. So -54, you can have a negative under a cube root, right? Because isn't a negative times a negative times a negative a negative? But 54 is not a perfect cube. So we want to figure out what's the biggest perfect cube that divides evenly into 54. So I'm going to list some perfect cubes off to the side. So 1 cubed is 1, 2 cubed, 2 cubed, 2 times 2 times 2 is 8, which does not divide into 54. 3 cubed, 3 times 3 times 3 is 27, which does divide into 54, right? 27 times 2. So that's actually the biggest perfect cube that divides evenly into 54. Now you also, if you can, you want to try to get the negative out from under the radical. So what we're going to do is when we break this up into 2 separate cube roots, I'm going to put the negative with the 27, I'm going to put the negative with the perfect cube, and I'll put the leftover 2 right here. Now, another thing I don't want to forget is since there's a square on here, I'm going to need to put a square on each of these. All right, and then the cube root of negative 27. So if you want to say what times itself gives you negative 27, it's negative 3. So I'm going to actually skip ahead to the next step. So we're going to have negative 3, and we're not going to forget about this square right here. And then I'll just bring down the cube root of 2 squared. Okay. And then, let's just stick with this. So since negative 3 squared is equal to 9, we're going to have 9. And I'm kind of looking ahead at the answer choices here. So if you notice, all the answer choices, none of them have a 2 under the radical. They all have a 4. And what they did to get that 4 was they took this exponent, this 2 right here, and instead of having it outside the radical, they put it on the inside of the radical like that. So now we have the cubed root of 2 squared, which is 4. All right, so I'm going to write that as the cubed root of 4. Now, if you look at the answer choices, we could automatically eliminate choice 1 and choice 2 because they have i's in there. And if we take a look, I'm going to just kind of now, we have 9 times the cube root of 4, which we have a 9 here, the cube root of 4, a 9 here, and the cube root of 4. And if you notice, both of these numerators also have, see this x to the 6th that I had in the numerator? Let's keep bringing that down, right? X to the 6th, x to the 6th. And what they did was, instead of putting it over here, they wrote everything before the radical. They wrote 9 x to the 6th times the cube root of 4. Okay, so that's how they ordered that. Now let's just work with the denominator because that's the difference between choice 3 and choice 4. So in the denominator, let's go back up here. We have y to the 8/3. So using power over root, we can rewrite that as the cube root of y to the 8th power. Now, since you always want to simplify a radical, since y to the 8th, right, there's nothing times itself that gives you y to the 8th. You might, 8 is a perfect cube because 2 times 2 times 2 gives you 8, but y to the 8th, there's nothing that you can multiply by itself to give you y to the 8th. Remember, in order for something to be a perfect cube, the exponent has to be a multiple of 3, right? This list would just keep going and going. So if we look on this list, y to the 6th is the biggest perfect cube that divides evenly into y to the 8th. So I'm going to break this up into the cube root of y to the 6th and the cube root of y to the 8th. I'm sorry, y squared, right? The leftover 2. All right, so now the cube root of y to the 6th is y squared because doesn't y squared times y squared times y squared give you y to the 6th, right? When you multiplying terms with the same base, you add the exponents. So this is going to be y squared. Or even easier, if we did y to the power over root, isn't 6 divided by 3? 2. And then I'm just going to take down this cubed root of y squared and put it in the next step. So now, if you look at your answer choices, choice 4 has got to be the answer because that's where we have y squared times the cube root of y squared in the denominator. All right, number 20. So they give us two functions, f of x and g of x, and they want to know when do these two functions equal each other. All right, so in order to do this, all you have to do is just basically in your calculator, go to y1, and you're going to plug in f of x, and go to y2, and plug in g of x and just look for a point of intersection. Now, when they phrase it, like this, when does f of x equal g of x? If we took what f of x was equal to and set it equal to what g of x was equal to, you'd notice we only have x's, in that equation. So when we're looking for the point of intersection, this is important, for the x value only, or x values, I should say, depending on how many there are. So you can automatically eliminate choice 3 and choice 4, because look, these are written as coordinates, as x and y. We want the x value only. Okay, so when you graph this in your calculator, what you'll notice is that f of x, I'm just going to do a real quick sketch, but f of x looks something like this. And g of x, let's see, looks like, this is again just a quick sketch, looks something like this. Now, in your calculator, if you're just looking at your normal 10 by 10 screen, you'll probably only see, you probably won't even notice this point of intersection up here. You'll probably just see these 2 points of intersection. So anyway, in your calculator, if you go to second, trace choice 5 and find this point of intersection, the coordinates of this are negative 0.99, comma 1.96. So again, we're looking for the x value only. But I don't see that x value as one of the answer choices. So if we find this next point of intersection, so again, you go to second trace, choice 5, move the cursor over by the point of intersection and hit enter, enter, enter. We'll see we get 0.50, which again is not up here. So what we're going to need to do is do second trace intersect and move our cursor a little bit out of the screen to this third point of intersection. So you're going to have to keep scrolling till you get there. And when you do, you'll see, when you do again, second trace intersect, choice 5, you'll see this was way out of the screen. It occurred at a height of almost 33. You'll see this is the point we get, so 11.29, choice 2, is the x value of that point of intersection. Number 21, the Rickards decided to set up an account for their daughter to pay for her college education. The day their daughter was born, they deposited $1,000 into an account that pays 1.8% compounded annually. Okay, beginning with her first birthday, they deposited an additional $750 into the account on each of her birthdays. So basically, every year they were depositing an additional $750. Okay, so I think what I'm going to do here is I'm going to just kind of organize the information. So initially, so I'm going to call that A sub 0. They put in $1,000. Okay, then each year after that, well, I should just say each year it grew by 1.8%, and then they deposited an additional $750 each year. So let's say after the first year, they would have the $1,000 they deposited times 1.018, right? Because it's growing, it's 1 plus the rate, it's growing at 1 plus 1.8%. Okay, and then in addition to that, they're going to deposit $750. Okay, so really at the end of the first year, if you figured out what A sub 1 was equal to, that would be approximately $1,768. Okay, now at the end of the second year, they're going to have that money that's in the account being multiplied by 1.018, right? Because again, we have a growth rate of 1.8%, and then they're going to deposit an additional $750. So if we figure out what that's equal to, that would be, I'm just going to round here, approximately $2,550. Okay, so now that trend is going to continue. So as you're seeing, what's happening is A sub n, after the nth year, it's going to be equal to, and it's just the same thing that's happening here, the previous year times the rate plus $750. So the previous year we'll call A sub n minus 1. We'll multiply that by the rate, and add on $750. Okay, so now let's look at the answer choices. Now, if you look at answer choice 1, okay, this says you're taking $1,000 and multiplying it by the rate to the n power plus 750. That's not what's happening here. You're taking the previous term and multiplying it by the rate and adding on 750. So choice 1 doesn't really kind of make any sense. All right, choice 2 says that it really says the same thing as choice 1, except what they're saying here is you're adding on 750 times the number of years that have passed. So that's like saying, you know, for the first year, if you replace this with a 1, they're putting in 750. For the second year, if you replace this with a 2, they're putting in 750 times 2, which is $1,500, and so on. That's not the case. It says they deposited $750 into the account on each of her birthdays. So choice 2 is definitely not the answer. And that being said, choice 4 can't be the answer because these right here are both recursive sequences, formulas, and if you look, they're again putting 750 times the number of years that have passed. That's not true. They're putting in a set amount of 750 each year, so choice 4 can't be the answer either. So I guess choice 3 it is. Let's see why. So choice 3 says they're depositing $1,000 initially, which is what we have here. A sub 0 is 1,000, and then they're taking the previous term and multiplying it by the rate, 1 plus the rate, and adding on 750, which is exactly what this says here. So choice 3 is the answer. All right, 22. When g of x is divided by x plus 4, the remainder is 0. Okay, let's just talk about what that means. When this function is divided by x plus 4, the remainder is 0. All right, the remainder tells us a lot. The remainder, first of all, the remainder tells us that x plus 4 is a factor of g of x. It means it's going to divide evenly into it. Okay? And so actually looking at the answer choices, if we want to know which conclusion is true, choice 3, I could say, is not the answer because that says x minus 4 is a factor. If it said x plus 4 is a factor, that would be your answer. But if x plus 4 is a factor, what that means is if you take x equals negative 4, if you take the 0 that's associated with this and substitute it into g of x, the function will be equal to 0. Okay, so again, if x plus 4 is a factor, that means if we take x equals negative 4 and substitute it in for g of x, this function right here will be equal to 0. Okay, so, I mean, actually that's right here what choice 2 is saying. G of negative 4 equals 0. So that's your answer. All right, so choice 2 is the answer. Now, just to kind of double check, if we find g of negative 4, so basically you're going to take negative 4 and substitute it for all the x's right here, you will see that the function is equal to 0. So let's do it. So we have negative 4 to the 4th plus 3 times negative 4 cubed. So we're just taking all the x's and replacing them with negative 4's in parentheses. Okay, so, I mean, if you figure out what all of this is equal to, you can figure it out like a little bit at a time if you want, or you could just plug this whole thing in your calculator, or even easier, right? Type in negative 4, store x, and type this into your calculator and hit enter, and you will see that it does equal 0. Okay, so choice 2 is the answer. Okay, so as you can see, I just plugged it right into the formula. I did y2 minus y1 over x2 minus x1. And then if you subtract the numerators, subtract the denominators, and divide them, you should get 28.398. Okay, so 32.398. All right, so now you have to repeat the process for each one of these. Okay, so for choice 2, if we're looking from month 19 to month 69, we would just do y2 minus y1 over x2 minus x1, and that's what I did here. And then you wind up getting 32.76. All right, so far that's bigger than choice 1, so we know choice 1 is not the answer. All right, so let's keep going. Let's look at choice 3. Okay, so choice 3, we're looking from month 36 to month 72. So again, y2 minus y1 over x2 minus x1. And when you subtract the numerators and then subtract the denominators and then divide those two answers, you wind up getting 37.917, which is higher than choice 2. So choice 2 can't be the answer either. Okay, and finally choice 4, we're just doing month 60 to month 73. So following the same formula, we wind up getting, this one looks like it's going to be the highest. We wind up getting 45.7. So choice 4 has the greatest average rate of change. Okay, number 24. Which graph represents a cosine function with no horizontal shift? All right, so let me stop there. If we take a look at choice 1, that's a positive cosine curve. And choice 3, that's a negative cosine curve. We can automatically eliminate choice 2 and choice 4 because those are sine curves, right? Sine curves we know start on the midline. Okay, now it says it has an amplitude of 2. So choice 1, the amplitude is the height from the midline. So choice 1, well, that has an amplitude of 2, right? This is the height is 2 units up from the midline. But also choice 3 has an amplitude of 2. The height of this is 2 units up from the midline. So that doesn't really help us. This is what's going to help us. It says the period is 2 pi over 3. Okay, now if we think about what the period means, right? The period is the horizontal length of one complete cycle. So they're telling us one complete cycle takes 2 pi over 3 units. Now if you look at choice 1, here's 2 pi over 3. This is not showing one complete cycle. This is showing, let's see, we have 1, 2, 3 complete cycles. So here, the period is not 2 pi over 3 because we would have to fit one complete cycle by the time we got there. So choice 1's not the answer, but let me just go over why choice 3 is. All right, let's also think about the formula for the period. We know period is equal to 2 pi over the frequency. Okay, so that's going to be equal to 2 pi over. Now, the frequency, okay, so the frequency is the number of complete cycles in a span of 2 pi units. So if you look at choice 3 right here, see this is where 2 pi is. In a span of 2 pi units, we fit, I'm going to, I guess, color code it again, 1, 2, 3 cosine curves. So the frequency of this curve right here is 3. So we could replace this word frequency with a 3. So if we look here, it says period is equal to 2 pi over 3, which is what we wanted in the original question. So choice 3 is the answer. All right, number 25 says given equal terms. So if these two terms are equal, I guess what we should do is set them equal to each other. So we have the cube root of x to the 5th being equal to y to the 5/6 power. And what they want us to do is they want us to, it says determine and state y. All that means right there is solve for y. And then when it says in terms of x, that means that there will be an x in our final answer. Okay, so let's take a look at this. Now, first thing I would probably do is I would take this out of radical form. When you want to try to solve an equation or combine terms, it's better off to get it out of radical form. Now, we know that saying power over root. So since this is our power and this is our root, we can rewrite this as x to the power over root, x to the 5/3 power. Now, if they want us to solve for y, right, what we need to do is we need to get this exponent right here off of the y. We want to be left with just y to the 1st power. So in order to do that, what we're going to do is we're going to raise both sides of the equation to the reciprocal power of this exponent. So the reciprocal of 5/6 would be 6/5. And if we do that to the right-hand side of the equation, we have to do that to the left-hand side of the equation. One thing I want to point out, please make sure you put your exponent on the top right. I see sometimes people try to put it on the left because they're like, ooh, it'll fit better here. But an exponent always goes on the right of the base. Okay, now, let's take a look at why we did this. The reason we did this is because over here, when you raise a power to another power, you're really multiplying. So if you multiply these numerators, we'll have 30, and if we multiply the denominators, we'll have 30. And isn't 30 divided by 30 just 1, so it leaves us with y to the first? Or even easier, what I like to do is I like to say this 5 in the numerator cancels off with this 5 in the denominator, and then the 6 in the numerator cancels off with the 6 in the denominator, leaving us with just y to the first. Okay, now on the left-hand side of the equation, we're going to have a base of an x, and let's do the same thing. Let's multiply these exponents. So 5, you could just cross off this 5 on top with this 5 on bottom, and then you'll be left with 6 over 3, which becomes 2. Or you could say, if we multiply the numerators, we get 30, and if we multiply the denominators, we get 15. And 30 divided by 15 simplifies to 2. So this is our answer. Y is equal to x squared. Okay, we solve for y, and it's in terms of x. We have an x in our answer. All right, so number 26 is it's a unique question. Mrs. Jones had hundreds of jelly beans in a bag that contained equal numbers of 6 different flavors. Her student randomly selected 4 jelly beans, and they were all black licorice. Her student complained and said, "What are the odds that I get all of that kind?" Mrs. Jones replied, "Simulate rolling a die 250 times and tell me if 4 black licorice jelly beans is unusual. Explain how the simulation could be used to solve the problem." All right, well, since there are 6 different flavors of jelly beans, and we have 6 numbers on a die, what you could do is you could just assign each flavor to a number. All right, so so for example, the black licorice might get assigned to the number 3. And then from there, you would just use the simulation, right, that she says of rolling a die 250 times to see the number of times the die lands on the same number 4 times in a row. Okay, so here it is, just kind of written out for you. Okay, so number 27, while experimenting with her calculator, Candy creates the sequence 4, 9, 19, 39, 79, and so on. Write a recursive formula. Let me just underline that word recursive, because we don't want to write an explicit formula, for Candy's sequence. All right, so we know with a recursive formula, what we have to do is we have to kind of have 2 separate terms. We need to show what the first term is equal to, as well as what the nth term is equal to. Now, we know right here the first term is equal to 4, so that's the easy one. So we're going to make that a 4. Now, here we want to show, what do you have to do to the previous term in order to get, the current term, in order to get, what the next term is going to be. So you kind of have to look and see what pattern is going on here. Now, it might, take a little bit of thought, but what we're doing is we're doubling the previous term and adding 1 to get to the next term. Okay, if you take 9 and double it, that gives you 18, and you add on 1, that gives you 19. If you double 19 and add on 1, it gives you 39, and so on. So what we're doing is we're, again, doubling the previous term. So I'm going to write down here 2 times, and remember, a sub n minus 1 represents the previous term, and we are adding on 1 to that. So this would be our recursive formula. Now, what they want us to do is they want us to determine the 8th term in the sequence. Okay, so the first 5 terms are written out for us here, so a sub 1 through a sub 5. So what we want to do is we want to keep going until we get to the 8th term. So if you take the 5th term and multiply it by 2, that gives you 158. So if you add on 1, that gives you 159. So the 6th term is equal to 159. Okay, if we double 159 and then add on 1, that'll give us the 7th term, which is 319. And then finally what they're asking for is a sub 8. If we double the 7th term and add on 1, that'll leave us with 639. Okay, 28. The results of a survey of the student body at Central High School about television viewing preferences are shown below. Are the events student is a male, I'm going to do M for male, and student prefers reality series, I guess I'll do R for realities, for reality, independent of each other. Okay, justify your answer. All right, so we know that two events are independent if this rule works, if the probability of male and reality equals the probability of male times the probability of reality. All right, so let's look at our table and let's see if we can figure out these probabilities. So the probability of being both male and preferring reality series. So here's our males, and here's our reality series. So this is where they intersect. So 70 people are males and prefer reality series. Now, because it says probability, we have to put that over the total number of people we're looking at here, which is 490. Okay? Remember, when we're talking about probability, you're always going to use this total as your denominator unless it says or implies the word given. Only does your denominator change if you're given a certain row or if you're given a certain column. Okay, so now on the right-hand side of the equation, the probability that a student is a male. Well, let's see, males, altogether we have 230 males out of the 490 students that go to the school. Okay, and then the probability of preferring a reality series is, well, altogether 180 students prefer a reality series out of the 490 students. So 180 out of 490. So now we just want to see if these two sides of the equation are equal to each other. All right, well, if you plug this into your calculator, you can hit math, enter, and it actually changes it to 1/7 for you. Now, if you multiply these two fractions, I'm going to actually change that answer to a fraction as well, just because we did on this side, and hit math, enter. It actually changes to something different. Okay, it changes to 414 out of 2,401. So these are not equal. So because they're not equal, we could say that the events are not independent. Okay, so I'm just going to say here, the events student is a male and student prefers reality series are not independent because, and then make sure you state that rule. Here I use the and symbol instead of the word and, just so you're able to see it both ways, but you can use whatever you want. Okay, 29, they give us f of x and g of x, and they want us to state the quotient, which means to divide, and the remainder of f of x divided by g of x. And when they want it in this form, I'll explain what that means when we get to the end. Okay, so we want to take f of x, which is 3x squared plus 7x minus 20, and we want to divide that by x minus 2. Okay, so we're going to use long division. So you want to look and say, what do I multiply x by to give me 3x squared? Well, 3x. So we're going to put a 3x up here, and we'll distribute that to the x minus 2. So 3x times x is 3x squared. And then 3x times negative 2 is negative 6x. Okay, now we want to show we're subtracting, we want to change our sign and circle, change the sign and circle. Okay, so these cancel off. And then when I combine 7x plus 6x, that gives me 13x. And I'll bring down the minus 20. All right, so let's start the process again. What do I multiply x by to give me 13x? 13. So I'm going to put plus 13 up here. And now we distribute the 13 to the x minus 2. So 13 times x is 13x. And then 13 times negative 2 is negative 26. And then we're going to change our sign and circle, change the sign and circle. So those cancel out. And negative 20 plus 26 is positive 6. So that's our remainder. So then we're going to put our remainder as plus the remainder over what we were dividing by. So this is our answer, and let me just show you why it matches up with the form they want. Okay, q of x represents the quotient of x, which was the 3x plus 13. And then plus r of x is the remainder of x, which is 6, over g of x, which is what we were dividing by, which is x minus 2. Okay, number 30 wants us to factor completely. So first thing you want to do is you want to look and say, can you factor out a greatest common factor? And no, we can't. So we're going to jump right in and see if we could do factor by grouping. So if we group together the first two terms, we could pull out an x squared which would leave us with 4x minus 1. And out of the next two terms, we can pull out a positive 4, which would leave us also with a 4x minus 1. So we know we're on the right track because what's in the parentheses matches up. So now you're going to take what's on the outside of the parentheses, the x squared and the plus 4, and we're going to group those together. And we're going to take this binomial, which is, it's written twice, right? But there's technically only one of them, so we are going to write it just once. Now you want to look and say, can I factor further? If you have two terms, I mean, you're really looking for, as long as all the greatest common factors are factored out, you're just looking for a difference of perfect squares, which if you look at both of these parentheses, I mean, the first parentheses doesn't have a subtraction sign, so that's not a difference. If it was, we could have factored that further, but it's not, so we can't. And then the second parenthesis, I mean, this is not a perfect square, although we do have a difference, and this is, so we can't factor that further either. So that is our final answer. Okay, number 31. The graph below represents the height above the ground, so this is the height in inches, of a point on a triathlete's bike wheel during a training ride in terms of time t in seconds. So this is time t in seconds. Okay, identify the period of the graph and describe what the period represents in the context of the problem. Okay, so, well, we know the formula for period. Actually, we don't even need the formula here. I mean, the period is just the horizontal length of one complete cycle. So if you notice, this from here to here is one complete cosine curve. So that takes 2/3 of a second. So the period is 2/3. Okay, and it says to identify what it means in the context of this problem. So, I mean, all that means is that it takes 2/3 of a second for the wheel to make one complete rotation. So if you pick a point on the wheel, it takes 2/3 of a second for the wheel to make one complete rotation. All right, so number 32 just wants us to graph the given equation on the set of axes below. And it looks like they already set up the x and y axis for us. So all we're going to do is we're going to go to y equals in our calculator and plug this in and look at the table of values and just copy down those points. All right, so here was my table of values in the calculator, and they did already give us the 100 and the 400 along the y-axis. So I just, counted. I saw every 5 boxes was 100, so I put the 200, the 300. And along the x-axis, they gave us the 1 and the 10, so I filled in the missing numbers, and I did the best to plot these points most accurately. Keep in mind, you have to label your equation, and it's a good idea to put the arrows. I mean, technically, if you graph all the way from one end of the graph to the other, it's implied the graph is going to keep going, but the arrows really shows, all right, this graph continues on. Okay, so number 33 talks about looking at meat that's kept in room temperature under a microscope and the average number of spores they see based on the time that has passed. Now, what they ask us to do is it says using the data, so using this data right here, they want us to write an exponential regression equation. So this is something the calculator does right for us, okay? So what we're going to do, we're going to follow these steps right here in our calculator. So first thing you're going to do is in your calculator, you're going to find the Stat button, and it says Edit. So you're just going to hit Enter right there, and you're going to enter this first column into L1 and the second column into L2. So it's going to look just like this. Okay, then you're going to clear out of here. You're going to go to your home screen, right? Second mode, so quit. You're going to go back to Stat. This time you're going to go over to Calc, and you're going to scroll down until you see Exponential Regression Equation. When you pick that, just scroll down to Calculate, and then hit Enter, and this is what you should see in your calculator. So they're telling you this is the setup of an exponential regression equation, right? We have y equals some number times some other number to the x power, and they tell you what these numbers are. All you have to do is just take them and plug them in. Okay, so they want us to round to the nearest thousandth, so I took the 4.168, right, that now rounds it up to an 8, and substituted it in for the a, and I took the 3.981 and substituted it in for the b, and just raised it to the x power. Okay, now that's the first part. The second part says, it starts here. The researcher knows that people are likely to suffer from foodborne illness if the number of spores exceeds 100. Using the exponential regression equation, determine the maximum amount of time to the nearest quarter hour that the meat can be kept at room temperature safely. Okay, so when the spores exceed 100, so they're saying that y represents the average number of spores. So we need to replace this y with a 100. Okay, so this is what we're going to solve. And make sure you don't just erase the y and change it with a 100, because then you fail to answer the first part of the question. They first needed an equation, which means in terms of x and y. And an equation, don't forget, you have to put the y equals. And then in the second part, that's where we replace this with a 100. And now we can solve. Okay, so to solve this, we're solving for an exponent. So since this exponent is only on this base of 3.981, we need to get this base to the x power by itself. So to get rid of the 4.168, let's just divide both sides of the equation by 4.168. Okay, I'm going to keep this as this ugly fraction, just so that I'm not rounding within the problem. So I have 100 over 4.168 equals 3.981 to the x power. Now, in order to get our x out of the exponent spot, what we do is we put the word log in front of both sides of the equation. And the reason we do that is because the power rule tells us we can take that power and bring it to the front of the word log. So now I'm just bringing down the left-hand side of my equation, and I'm rewriting the right-hand side of the equation with the x in front of my log term. Okay, so now if I want to get this x by itself, just divide both sides by log of 3.981. And you're literally just going to plug this in the calculator. Okay, so when we do, we wind up getting approximately 2.3. Okay, now if we look here, it says to round to the nearest quarter hour. So if you think about a quarter's worth, right, like a quarter, 25 cents, if you have two of them, 50 cents, three of them, 75 cents, four of them would be $1, right? Your decimals are going to end in either 0.25, 0.50, 0.75, or 0.00. So you want to look at this, 0.3. Is that closer to 0.25 or 0.50? Well, 0.3 is closer, right? 30 is closer to 25 than it is to 50. So this would round to 2.25. So 2.25 hours. And the Regents would also accept 2 hours and 15 minutes, because isn't a quarter hour 15 minutes? Okay. All right, number 34. So I actually love when they put these on, because once you guys get the hang of how to do these again, you were great with these. Okay, so first thing you want to do is, if they give you 3 equations with 3 variables, we want to plug this in our calculator and find out the answers ahead of time. Don't wait till the end, because you want to find out if you made a mistake before you get to the end, because then if you wait, you got to backtrack throughout every step. All right, so let me just show you the steps for doing it in the calculator first. Okay, so the first thing we want to do is, in the calculator, you're going to go to second, x inverse. That's along the left-hand side. You'll see it says matrix on top. You're going to go over to edit, and you're going to create a 3x4 matrix. All right, so it's going to look like this. Okay, so I know you can only see like 3 numbers here. There's actually a 4th number over here. If you look, see how it goes 1x, 1y, 1z, and then 1? I have a 1, 1, 1, and if we could see over here, there'd be a 1. Then see how the numbers go 2, 4, 6, 2? We have 2, 4, 6, 2, and so on. All right, after you finish plugging that in, you're going to clear out of there. You're going to go to a home screen. So second mode, you're going to quit out of there. Then you go back into matrix, and this time you're going to scroll over to math, and you're going to scroll all the way down. It's actually faster to scroll up until you get to letter B, which says RREF. Now from there, you're going to go back to second matrix for a 3rd time, right? And you're going to hit enter on matrix A. You're going to choose matrix A, and this is what you should see. Okay, so what this means is 1x is equal to 0. Since this is in the y column, 1y is equal to 2. And since this is in the z column, 1z is equal to -1. So basically this last column gives you your answers. All right, so x equals 0, y equals 2, and z equals -1. Okay, so now we could start the problem. Now we could do this algebraically. All right, so to do this algebraically, the first thing we want to do is we want to label our equations A, B, and C. That way as we do the work, whoever's grading your paper knows exactly what you're doing when. It makes it nice and easy for grading. Also, what we require you to do is you have to write step 1, step 2, that way we know, if you have work all over the place, it's easy to follow. So step number 1. All right, so we want to line up 2 of the equations, and we're hoping to get one of the variables to cancel out. So, I mean, if you look at equation A right here and equation C, you could see right off the bat, if we line them up, the x's will cancel out. So I think that's probably a good move to start off with. So we're going to line up equation A, so let's put in A. And then we can just write x plus y plus z equals 1. And then let's line up equation C. So that's -x plus 3y minus 5z equals 11. And if we add those together, the x's cancel, which is what we wanted to happen. And that leaves us with 4y minus 4z equals 12. So since we created a new equation, let's give that a label. We'll call that equation D. Okay, now, step number 2, what we want to do is we want to go back to the original equations, and we want to choose another pair of equations, 2 other equations, and you again want to try to get the x's to cancel out. If you get the x's to cancel out in step 1, you have to get the x's to cancel out in step 2. So I'm going to use, let's see, if I multiply equation A by -2, this will become a -2x, which will cancel off with the 2x in equation B. So what I'm going to do here is I'm going to do -2 times A, and I'm going to use equation B. Now, if you do -2 times A, what we need to do is we need to multiply every term in A by -2, even the right-hand side of the equation. So this will become a -2x, a -2y, a -2z, and don't forget to multiply this by -2, so that's going to be equal to -2. All right, and then let's just bring equation B down. So 2x plus 4y plus 6z equals 2. All right, so now our x terms cancel off, and -2y plus 4y is positive 2y. -2z plus 6z is positive 4z. And then we have a -2 and a positive 2, so those actually cancel to give us 0. So now we created again another equation, so we're going to call that equation E. All right, so now step 3, what we do is we have to line up equations D and E, and we're hoping to get either the y's to cancel out or the z's to cancel out. Now this one they couldn't have made easier for us. Wow, look at this. If you line these up, we don't even have to multiply one of the equations by anything. The z's just cancel out for us. All right, so this is a pretty straightforward one compared to some of the others we do. So in step 3, I'm going to line up equation D and equation E. So equation D is 4y minus 4z equals 12. And equation E is 2y plus 4z equals 0. And what's going to happen is the z's cancel off. So that leaves us with 6y equals 12. And I'm kind of running out of room. When we divide both sides by 6, that's going to leave us with, I'm just going to put this over here, y equals 2. Now, the reason why we used our calculator first to find the values is because once you finish solving for one value, we're going to check with what our calculator gave us, and look, these match up. So we know we're on the right track. If you end up getting a different value, this is where you'd want to go back and try to find your mistake. But we're good so far, so let's go on to step 4. Okay, now once you find your first variable, you can go back to either one of those 2 equations that you created, so equation D or equation E, and you're going to solve for the variable we don't know yet. So since we know y, I'm going to use equation E, that one looks easier to me. Since we know what y is equal to, we're going to solve for z. All right, so we're going to use equation E, and equation E says 2 times y. Now we know y is 2, so I'm going to replace the y in this equation with a 2. So we'll have 2 times 2, and then plus 4z equals 0. So what we have to do is just solve for z. So 2 times 2 is 4. So we have 4 plus 4z equals 0. And then just subtract 4 from both sides of the equation. So that gives us 4z equals negative 4. And when we divide by 4, that gives us z equals negative 1. Now let's stop and see if that matches up with what our calculator gave us, which, look at this. Yes, it does. So we're doing good so far. All right, and then step 5, you can go back to any one of the 3 original equations and solve for the variable that we don't know yet. So we don't know x. To me, equation A looks the easiest. So I'm going to use equation A, and we're going to solve for x. Since we know that y equals 2 and z equals negative 1, I'm going to replace them with those numbers and solve for x. So we'll have x. Let me write down, I'm using equation A. So we'll have x, and then plus, since y is 2, we're going to replace that. And since z is negative 1, I'm going to write minus 1, and then I'll bring down this equals 1 on the right-hand side of the equation. All right, so let's solve. Since positive 2 and negative 1 combine to give us 1, we have x plus 1 equals 1. And then just subtract 1 from both sides of the equation, and that leaves us with x equals 0, which again matches up with what our calculator gave us. So when you finish one of these, you pretty much know if you got it right or not. All right, the guidance department has reported that of the senior class, 2.3% are members of the Key Club. I'm just going to kind of underline some things, which they're calling K. All right, 8.6 are enrolled in AP Physics, which they're calling P, and then 1.9 are both. Okay, so determine the probability of P given K to the nearest tenth of a percent. So nearest tenth of a percent. So it means we have to change it to a percent and then round to the nearest tenth. All right, so first thing, we have to know our given formula. The probability of P given K is equal to the probability of P and K over the probability of what we're given, so the probability of K. Okay, so the probability of P and K is right here, okay, the both, the 1.9%. So I'm going to actually take that out of percent form. I'm going to move the decimal place back twice and write it as 0.019. But to be honest, even if you left it in percent form, you would still get the same answer in the end as long as you did the same in the denominator. Okay, the denominator wants to know the probability of K. So it says right here, 2.3% are members of the Key Club K. So if I move this decimal place back twice, it gives me 0.023. All right, now if you divide these in your calculator, it gives you approximately 0.826. And because they want us to change to the nearest tenth of a percent, we first change to a percent by moving the decimal twice, and then to the nearest tenth, that would be 82.6%. Okay, the principal would like a basic interpretation of these results. Write a statement relating your calculated probabilities to student enrollment in the given situation. So, they want to know, what does this number actually represent? Well, since we're given K, okay, we're given that a member is in a Key Club, what that means then, that if a member is in a Key Club, right, we're only looking at these members, so if a senior is a member of the Key Club, there is an 82.6% chance that, I'm going to say, they are also enrolled in AP Physics, okay, that they're in both. So let me just write that out. All right, so there we go. There it is in words. All right, so 36 wants us to solve for all values of P. So the first thing we want to do is we want to find a common denominator. So if we look at the denominators, we have a P minus 5, and both of these have a P plus 3. So in our common denominator, we're going to want to include both of those. All right, this might be a little tricky for me to fit in here, but I'm going to try my best on here. All right, so the first denominator is missing the P plus 3, so we can put a P plus 3 in that first denominator as long as we also put it in the numerator. Okay, in the second fraction, we have the P plus 3, but we're missing the P minus 5. So let's multiply top and bottom of this fraction by P minus 5. Okay, and same thing with the last fraction. We're missing the p minus 5 in the denominator, so we will multiply the top and bottom by p minus 5. So now if you look, all three of these denominators have a p plus 3 and a p minus 5. And once they're all the same, you're allowed to just take them and cross them right off. So what we're going to do is we're going to solve this equation right here. Oop, I kind of crossed that off. That we're left with. All right, so let me rewrite this. This is so sloppy. So we have 3p times p plus 3. So 3p times p plus 3. Okay, then we have this subtraction sign. So we have minus, and then 2 times p minus 5. So minus 2 times p minus 5. And then equals, we have p times p minus 5. All right, so now we're going to just distribute. So 3p times p is 3p squared, and 3p times 3 is 9p. Now, we want to take this negative 2 and distribute it to both terms. And you know, that's why I kind of like rewriting this first, because if you up here, if you don't rewrite it, a lot of times people bring down the minus sign and just distribute a positive 2 to both terms, which is going to get us the wrong answer. Here we could clearly see we're taking a negative 2 and distributing it into the parentheses. So this will become negative 2p and then plus 5. I'm sorry, plus 10. So negative 2 times negative 5. So that's why we get the positive 10. All right, and then equals p times p is p squared, and p times negative 5 is negative 5p. All right, now, we need to combine our like terms, and also, we want to get, if we have squares within the equation, we want to get one side of the equation set equal to 0. So I'm going to set the right-hand side of the equation equal to 0, just so that I'm left with a positive p squared term. So I'm going to subtract p squared from both sides of the equation, and I'm also going to add 5p to both sides of the equation. Okay, so on the right-hand side, we're left with 0. Everything cancels. And on the left, 3p squared minus p squared is 2p squared. And then here we're going to combine all three of these terms. So 9p minus 2p is 7p, and 7p plus 5p is 12p. And then I'm just going to bring down my plus 10. All right, now to make our life a little easier, since all of these numbers are even, they're all divisible by 2, let's just divide both sides of the equation by 2. So that leaves us with p squared plus 6p plus 5 equals 0. All right, and let's factor. So if we want to factor, we'll set up 2 sets of parentheses, and we'll put a p in the first spot in each parenthesis. And then you're just coming up with 2 numbers that multiply to positive 5 and add to positive 6. So positive 5, positive 1. And when we make our t-chart, we get p equals negative 5 and p equals negative 1. Now what's really important is you want to make sure if you were to take these values and substitute them back into the denominators in the original equation, they don't create a 0 in the denominator. Because remember, a 0 in the denominator means we have an undefined fraction, so it doesn't exist. Okay, so let's check. So let's start with the negative 5. If you take negative 5 and substitute it in here, negative 5 minus 5 is not 0. And if I take negative 5 and plug it into either one of these two, negative 5 plus 3 is also not 0. So that does not create a 0 in the denominator, so that one's good. Okay, so now let's take the negative 1. So if we take negative 1, negative 1 minus 5 is not 0, and negative 1 plus 3 is not 0, so this one is fine as well. Okay, so 37. The value of a certain small passenger car, based on its use in years, is modeled by this function. So they're saying, all right, the value is modeled by this function, where v of t is the value in dollars and t is the time in years. Zach had to take out a loan to purchase the small passenger car. The function z of t, where z of t is measured in dollars and t is time in years, models the unpaid amount of Zach's loan over time. All right, so first thing they want us to do is, it looks like they want us to graph v of t and z of t over this interval. All right, well, that's pretty easy. All you have to do is go to y equals in your calculator and go to y1 and plug in this equation. And you're going to copy the points from the table of values going from 0 to 5. And you want to include these, right? If these are underlined, it means you want to include them. And then you can go to y2 in your calculator and plug in z of t. And again, go to the table of values and just copy down all the points from 0 to 5. And again, okay, so a couple of things I want to just mention. Make sure you label your axes, right? The y-axis is value in dollars, and the x-axis is time in years. Also, you want to start at time 0, and you want to end at time 5. Do not put arrows on these graphs, because if so, it would mean it keeps going, and we want to look at it just in this interval. We want to have a starting point and an ending point. Okay, in addition to labeling your x and y axis, you want to number them, and it has to be spaced out accordingly. And I mean, you may need to go to your table of values to look at how high the y-axis has to go. Okay, the x-axis, I mean, they gave to you, so you just space that out accordingly. But anyway, this is what our graphs look like, and make sure you label which equation is which. All right, so the next part wants us to state when v of t is equal to z of t to the nearest hundredth. So they want to know exactly when this happens if they want you to round to the nearest hundredth. So you're going to have to use your calculator, right? And, I mean, you can adjust your window to fit this. You can make your x min 0 and your y max 5. You can make your y min 0 and your y max 30,000. I mean, if you want to see the graph. And then to find the point of intersection, you would just go to second, trace, and choice 5. And just move your cursor, I guess, somewhere near this point, and hit enter, enter, enter. And when you do, to the nearest hundredth, you find the point of intersection to be approximately 1.95, and then 13,000. This is actually the only time I'm not going to put a comma in my number, because I don't want it to be confused with the comma that separates the x and the y. So 13,569.24. Now, if we want to figure out when v of t equals z of t, we're looking for the x value. Okay, we only want the x value only. So this right here at 1.95 years is when those two functions are equal to each other. Now it says interpret its meaning in the context of the problem. Now if you remember, we underlined that v of t represented the value of the car, and we also underlined that z of t models the unpaid amount on Zach's loan. So what this means is it takes approximately 1.95 years for the value of the car to equal the unpaid amount on Zach's loan. Okay, so just put it in words. So again, it takes 1.95 years for v of t, the value of the car, to equal z of t, the unpaid amount on Zach's loan. All right, Zach takes out an insurance policy that requires him to pay a $3,000 deductible, so let's underline that, in case of collision. Zach will cancel the policy when the value of his car, remember, value of his car was v of t, equals his deductible, which we said was $3,000. All right, so let's take the value of his car. Let's take what v of t is equal to. So v of t is this equation right here. We want to know when this is equal to his deductible, which is $3,000. So this is what we're going to solve. Okay, so since our exponent contains the variable, we know we're going to have to use logs. So we have to get the base that contains the exponent by itself. So let's first get rid of this number. Since we have this times this, the opposite of multiplication is division. So let's divide both sides of the equation by 28,482.698. Okay, so that leaves us with 0.684 to the t power equals, and I'm just going to leave this fraction as is. Okay, so now this is where we put the word log in front of both sides of the equation. And the reason we can do that is so that the t can come to the front of the word log. So that'll leave us with t times log of 0.684 equals log of this ugly fraction. Okay, so to get the t by itself, let's just divide both sides by log of 0.684. And that leaves us with t is approximately 5.9. Okay, now they want us to find it to the nearest year. So it will take him, rounded to the nearest year, 6 years to cancel his policy.